Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 1, May 2022, Time Zone 2. If you find this video is helpful, don't forget to subscribe and let your other friends know about my channel as well, so you guys can study together. And if your friend find my channel is helpful, they will also subscribe to my channel to support me to talk about other past papers as well. So let's get started. Okay, number 1, what is the concentration of chloride ions and mole decimeter cube in a solution formed by mixing 200 centimeter cube of 1 molar HCl with 200 centimeter cube of 5 molar of NaCl? For NCl minus in HCl, it's C times V, which is 1 times 0.2. It's 0.2 mole. 0.2 it's coming from 200 centimeter cube, and 1 comes from 1 molar of HCl. But for NCl minus in NaCl, that would be 5 times 0.2, so it's 1 mole. So the total mole, it's 1.2. All right, and V total here, it's 400 centimeter cube, so it will be 0.4 decimeter cube. So concentration total would be N total divided by V total, which is 1.2 divided by 0.4, so it will be 3 mole per decimeter cube. Okay, number 2. 30 grams of an organic compound produce 44 grams CO2 and 80 grams H2O as the only combustion products. Which of the following is the empirical formula of this compound? So 44 grams of CO2, we can find the mole first, which is 44 divided by molecular mass of CO2, which is 44 as well, so you will get 1 mole. And for hydrogen, that would be, okay, so H, so 18 divided by molar mass of H2O, which is 18 as well, so you will get 1 mole. Okay, so CO2 has only 1 atom of C, therefore for CO2 contains 1 mole of C, and for H2O contain 2 mole of H, as it is H2. So the total mass of C and H is 1 times 12 plus 2 times 1. So 1 mole times 12 relative mass of C, and then 2 moles of hydrogen times atomic relative mass of hydrogen, which is 1. So the total is 16. Okay, so the remaining mass would be 30 minus 18, which is 16 grams. So we can use this for oxygen. So N of O is 16 divided by the atomic relative mass of oxygen, which is 16, so you will get 1 mole. Therefore C1H2O. So the answer is D. Which graph represents the relationship between the amount of gas N and the absolute temperature T with all other variables in the ideal gas equation, PV equal to nRT held constant? Okay, the formula will be PV and RT. Let's arrange this. So T is the subject. So how to make it T as the subject? So we divide PV by nR, and we divide also with nR, so this will cancel, so T will be PV divided by nR. R is always a constant, and based on the question, P and V is also a constant, therefore this is a K. All right, So T will be K divided by N, or T is inversely proportional of 1 over N. All right, so the graph will be B. T is inversely proportional to N. Number 4. What is the relative atomic mass of an element with the following mass spectrum? So we have 23, 80%, 28, 20%. So this will be 0.8. This will be 0.2 times 23 times 28. You add them both, it will produce 24. Okay. What is the correct order for increasing first ionization energy? As you guys know, Na with atomic number of 11. So 1s2, 2s2, 2p6, and 3s1. Mg is 1s2, 2s2, 2p6, and 3s2, 3p1. And for Al, sorry, this is Al, and this is Mg, 1s2, 2s2, 2p6, 3s2. This for Mg12, Al13. Okay, Na requires low ionization energy compared to Al, and Mg, it has a lowest nuclear chain charge compared to Al, because Na with nuclear charge is +1, Mg +2, Al +3, and +1 Na, nuclear charge of Na is +1. It's weakly attracted to the nucleus due to shielding effect. Even though Al is further to the right place with nuclear charge +3 in the periodic table than Mg with the nuclear charge +2, the ionization energy is still lower compared to Mg, because the outermost electron of the Al, 3p1 here, this is the outermost electron, is in the 3p orbital. It is partially filled, cause some electron repulsion, so it makes it easier to remove. Mg has highest ionization energy as its outermost electron is in the 3s orbital. It is strongly attracted to the nucleus due to higher nuclear charge, so also there is no electron repulsion as well because it's a pair. All right, so the answer is B. Which are the most reactive elements of the alkali metals and halogen? Okay, so we have Li and caesium. As you go down the group, their reactivity increases, so caesium is more reactive compared to lithium. And fluorine and iodine. Fluorine is the most electronegative non-metal. It's the most reactive non-metal. So caesium and fluorine will be the correct pair as the most reactive alkali metals and halogens between these 4 options. Okay. Which of these ions are likely to be paramagnetic? Okay, paramagnetic means unpair of electron. So if we write down the electron configuration, that would be Ar 3d1, that would be Ar 3d3, that would be Ar 3d5. Okay, so this will be obviously unpair, this will be obviously also unpair, this will be obviously also unpair. So all of them. If you're not really sure how to write down here, so you can just, I will show you one of this example. So 22, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. So Ti is 3 plus, so you need to take 2 electrons from 4s, so 2, and then this 3d2, so we need to take 1 more, that's why it's 3d1. And for Cr3 plus, the last one will be 4s2, 3d4, this will be Ar, okay? It's for Cr3 plus with number 24. So 3 plus, you take 2 from here and then 1 from here, so 3D, 3 left, okay? And for Fe3 plus, number is 26, so it's Ar, and this will be for S2, 3D6. So 3 plus, you take 2 and 1 from here, so this will be 3D5. Okay, number 8. CrOH263 plus is violet and CrNH363 plus is yellow. What is correct? The answer is B. Okay, as CrOH263 plus appears to be violet, yellow light with this number of wavelength is absorbed. Complementary color are the opposite each other in the color wheel. The energy difference between EG set and T2G set determines the color of the complex, the splitting of the orbital. So the larger splitting caused by stronger ligand, which is NH3, result in the absorption of light in the yellow region, leading to the observed violet color in CrH2O63 plus. In which of the following compound does ionic bonding predominate? So HCl, it has covalent bond sharing electron between H and Cl. Both of them are non-metal. And NaF is an ionic. Na has low electronegativity, comes from group 1, and F comes from non-metal, and it has high electronegativity, so leading to transfer electron from Na to F. And for C, NH4Br, it's a covalent bond, so sharing between NH4 plus and then Br minus, therefore is covalent, and between N and H and Br also they share electron. So for NaOH, Na plus and OH minus. Okay, while ionic character between Na and O is there, but due to the electronegativity differences between O and H, so there is also a covalent bond here. Therefore, this one is more predominate. What is the main interaction between liquid CH4 molecules? So the Lewis structure of CH4 is like this. So you can see that the dipole moment is cancelled. So this one is non-polar molecule. So if it's non-polar molecule, is only London dispersion forces. If it has lone pair and then the dipole moment is not cancelled out, they will have a dipole dispersion force, and then if it has hydrogen bond, which is between hydrogen with nitrogen or with oxygen or with fluorine, then it will have hydrogen bonding. What is the formal charge of the oxygen atom in H3O plus? We need to write the Lewis structure to be able to calculate the formal charge. So this is the H3O plus. So formal charge, the formula is number of valence electron minus half times number of bonding electron, and then minus number of non-bonding electron. Okay, so for C, all right, so for for oxygen, so this oxygen, valence electron of oxygen is 6, and then bonding there are 3 bonds, so 6 electron, and non-bonding there are 2 electron here, so it will be +1. What is the molecular geometry of SF4? SF4, so 4
electron, so S comes from group 6, so there is 2 more electron here, so the domain is 5, so therefore the molecular geometry is seesaw. Okay, next, which statement is correct about identical pieces of magnesium add to two solution X and Y containing hydrochloric acid at the same temperature? But as you can see here, the same amount of magnesium, which is 0.05 gram, but the different concentration, so solution X is 1 molar, solution Y is 0.5 molar, and solution X has a lower volume compared to solution Y. The answer is solution X will reach a higher maximum temperature. Y. Solution X has a higher concentration compared to solution Y. Okay, it means faster reaction as there are more reactant particles in solution X to collide with Mg. But for the solution Y, has a larger volume, makes more space for the heat to dissipate, potentially lowering the max temperature reach. Therefore, solution X will reach a higher maximum temperature. Which equations represents hydration enthalpy? Hydration enthalpy is surrounding the gaseous ions by water molecule. So it should comes from gases first, and then when it is surrounded by water molecule, it become aqueous. So that would be A. As you know, lattice enthalpy is the first stage, first breaking apart an ionic compound into a gaseous atom, and then the second stage will be hydration enthalpy, where this gaseous atom that is already broken from an ionic compound will be surrounded by water molecule, so it becomes aqueous. Okay, what are the signs of delta H and delta S for a reaction that is not spontaneous at low temperatures but spontaneous at high temperatures? So at low temperature, okay, T should be small, therefore it will be non-spontaneous as at low temperature. If it's non-spontaneous, delta G should be positive. Okay, so to achieve delta G becomes positive, delta H should be bigger than T delta S. You know, delta G, delta H minus T delta S. So delta H should be bigger than T delta S. So delta S will be positive, therefore delta G will be positive as well, if you see from this formula. And at the high temperature, okay, T delta S also increases to make delta G becomes negative, so that would be spontaneous. Okay, since if delta H it's positive, so T delta S must be negative. Okay, if negative T delta S at delta G will be negative, therefore it will be spontaneous. So at low temperature, delta H is bigger than T delta S, and at high temperature, negative T delta S should be bigger than delta H. So both delta H and delta S must be negative. Which equation represents the bond enthalpy for HBr in hydrogen bromide? So the answer is B. This equation represents the breaking of the HBr bond in HBr into its constituent atom H and Br. As you know, bond enthalpy is the energy required to break 1 mole bond in a gaseous molecule. So B is the correct answer. Which term in the expression delta G equal to delta H negative T delta S is an indirect measure of the entropy change of the surroundings when divided by T. Okay, so delta G is a Gibbs free energy. It's used to measure spontaneity when temperature and pressure are constant. Therefore, it's not. Delta H is a change in enthalpy, which is used to measure heat absorbed or released by the system during a process. And delta S is a change in entropy, measure randomness or disorder of the system. And negative T delta S is an entropy change in surrounding, negative of the product of T and delta S of the system. So when we divide delta H by T, we can measure delta S as it is related to the heat or absorbed or released by the system, because that is about delta H. So when T is given, delta S of the surrounding occurs due to the heat exchange between the system and surrounding. So delta H is indirect measure of the entropy change of the surrounding when divided by T. Why does a reaction for a sample of gases at constant temperature occur faster at higher pressure? If pressure is high, gas molecules are closer together, therefore the collision is more frequent, will be occur. What is correct about the rate of disappearance of NO? Okay, so these are the rate NO squared. So as you can see that according to this rate, the rate of reaction is directly proportional to the concentration of NO squared. So if the concentration of NO decreases, the rate of reaction will also decreases. But through the equation here, okay, every 2 moles of NO consumed, 2 moles of H2 are also consumed. Thus, the rate of disappearance of H2 will be directly proportional with the rate of disappearance of NO. So it equals the rate of disappearance of H2. Okay, which energy profile diagram represent an exothermic SN1 reaction? So it's between the energy and reaction coordinate. So exothermic, as we know, that is let me just make it smaller. Okay, so for exothermic, delta H is of reactant is higher than product, so it's between C and D. But the first step is the rate determining step that requires more energy, as it involves the formation of carbocation. The second step occurs rapidly once the carbocation is formed, because it's SN1. Okay, so it needs to form carbocation first. So in forming carbocation, it needs more energy. So the energy that is the first step higher is C. And it proceeds to 2 steps. And the second step occurs rapidly once the carbocation is already formed in the first step. Therefore, the answer is C. Which factor influences the value of the pre-exponential factor A in the Arrhenius equation? A is the frequency of molecular collision and the orientation factor of reacting molecule. It is influenced by factors related to the nature of the reactant, such as their molecular structure, size, or shape, or concentration. So the answer is A. The equilibrium constant Kc for the reaction 2A plus 4B produced 2C plus 4D is 4. What is the value of Kc for the reaction below? So C plus 2D produce A plus 2B. As we can see, it's reverse and also half the equation. So C becomes from product becomes reactant, so it's reverse Kc to the power -1 as it is inverse, and half of the coefficient, which is square root. Okay, so first 1/4 and its square root, so 1/2, which is 0.5. 0.5 mole of I2 and 0.5 mole of Br2 are placed in a closed flask. The following equilibrium is established. I2 plus Br2 produce 2 IBr. The equilibrium mixture contains 0.8 mole of IBr. What is the value of Kc? Okay, so for I2, when it reacts with the Br2, produce 2 IBr. So 0.5 mole and 0.5 mole as well. And we don't know how many moles that would be reacted. So we can just say X, and then this is X minus X, okay? And for the product, that would be plus 2x because 2. So product is always plus, and then for the reactant is always a negative. So 0.5 negative x, 0.5 negative x, and this one will be 2x. So the equilibrium mixture contains 0.8 mole of IBr. Therefore, the equilibrium mixture contains 0.8 of IBr. So 2x equals to 0.8. X will be 0.4 mole. So this one will be 0.1, this one will be 0.1, and this one will be 0.8. So if we plot into the formula, that would be IBr squared, because the coefficient is 2, and then I2, and then Br2. So 0.8 squared minus 0.1 times 0.1, you will get 64. What happens to the amount of hydroxide ion and hydroxide ion concentration when water is added to a solution of NH3? When water is added to a solution of NH3 in water, it reacts with water to form NH4 plus and OH minus. These are the reaction. Okay, as NH3 reacts with water, it consumes water molecule and produces hydroxide ions. Thus, the concentration of hydroxide ions will increase. What is the strongest acid in the equations below? When you look at to the equation below, the expression would be Ka, so product, H2, ASO4 minus, and H3O plus. H2O will not give any effect, so that would be only H3, ASO4. And the Kc is 4.5 times 10 to the power -4. If Ka relatively large, okay, acid dissociates more completely, so it will be a stronger acid. If Ka, so stronger acid. If Ka relatively small, so the acid will dissociate less, it's a weaker acid. H3O plus is the numerator, indicating that a higher concentration of H3O plus correspondent to a larger Ka, meaning it's stronger acid. In the equation, H3O plus is also produced in the dissociation of H3ASO4. Thus, H3O plus is the strongest acid. As you can see that this curve is between strong base and then also strong acid. So to determine the pKb, this is pH, so half of the equivalence you will get pKa. So half, that would be around here, okay, here, around here, okay, so it's around 9 something, okay, it's around 9 something. So if pKa is around 9 something and pKa plus pKb is 14, so pKb will be 14 minus 9 something, that would be 4 point something, which is C. Okay, the key here to find the pKb, as it's pH, so it's pKa, and pKa, to find pKa we need to find the point where it is half of equivalence. So if you get pKa, and you can plug into this formula and you can get pKb. Okay, so next question: which species are both Lewis and Bronsted-Lowry bases? Okay, all of them. Why? Cn, it can donate its lone pair. Cn, both of them has lone pair, and OH has lone pair, and H3N has lone pair. So Cn, OH, and H3 can donate its lone pair, which is acting as a Lewis base. And Cn negative, OH negative, and H3 can also accept proton. Cn will form HCN, and OH will form H2O, and NH3 will form NH4+. That's why all of them are correct. Which combination best describes what is happening to chloromethane CH3Cl in the equation below? The reaction replaces Cl, chlorine atom, in chloromethane with the hydrogen atom. So it's a substitution. Number of hydrogen atoms increases while chlorine atom decreases in the product or reduction. Therefore, the answer is D. Number 29. The arrow represents electron flow in the diagram. What does terminal X on the battery represent? This is a voltaic cell. So for voltaic cell, positive electrode is at the cathode, and electrons flow from negative to positive in a wire. Okay, so what does terminal X on the battery represent? Cathode, and a positive terminal. Which E value in volt for the reaction MnSZn2 plus aqueous produce Mn2 plus aqueous and zinc solid can be deduced from the following equations. So we need this only from these three. So as you can see, Mn solid is on the left side, and for zinc 2 plus is on the left side. So we have zinc 2 plus is on the right side, Mn2 plus is on the right side, that's correct, and then zinc solid is on the right side, but here is on the left side. Therefore, we need to reverse this reaction. So you can see that if we take this as stay the same and this one reverse, so I will write it down here. So Mn solid plus 2Ag plus and aqueous plus this one will be on the reactant side plus Cu solid produce this one Mn 2 plus aqueous plus 2Ag solid plus zinc solid and Cu2 plus. Okay, what will happen now? Next, subtract the third reaction, which part of the combined reaction, as it's in the opposite direction. So we subtract the first and then the third. That would be MnS and 2Ag plus aqueous. So we copy it again. Zn2 plus aqueous and Cu solid. It will be minus Cu solid. Okay, and 2Ag plus produce Cu2 plus aqueous plus 2Ag solid. So we don't use this part anymore because we already copy it down here minus the reactant or subtract with a third reaction. So Cu2 plus will be eliminated by this one. So this one we don't use it anymore, the first one on the reactant side, but only on the product. Okay, and for 2Ag, that would be right here, and zinc solid we need it. Okay, and MnS we need it, and Zn2 plus we need it, and Cu obviously finish, and 2Ag would be finish. Okay, and Mn2 plus we need it. So we'll produce Mn solid, zinc 2 plus aqueous, Mn2 plus aqueous, and zinc solid. Therefore, the total will be E reduction minus E oxidation. Okay, so reduction would be this, and then so that would be 1.98 minus 1.10 minus 0.46. So why it is minus? Because this one is negative reverse. You will get 0.42. What is the order of increasing mass deposited by this electrolytic cell? So we have Ag, Cu, and Sb. Okay, according to Verday's law, the mass of a substance deposited during electrolysis directly proportional to the quantity of electricity passed through the cell. The mass of the substance deposited during electrolysis is directly proportional to its equivalent weight or equivalent mass. So we need to find the equivalent weight or equivalent mass of the substance, which is molar mass, okay, divided by number of electron involved. Okay, so for Ag, electron involved, so Ag plus NO3 minus, Cu2 plus, SO4 2 minus, and this one Cl minus, Sb 3 plus. Okay, so for Ag, that would be 1 electron, and the Ar is 108, so that would be 108. And for Cu, it's 2 electron, 64 divided by 2, so that would be 32. And for Sb is 122 divided by 3 is 40.67. So the smaller the equivalent weight, the greater the mass will be deposited. Therefore, Cu is smaller than Sb and is smaller than Ag. So the answer will be D, because the mass of the substance deposited during electrolysis is directly proportional to its equivalent weight or equivalent mass. Okay, so the smaller the equivalent weight, the greater the mass will be deposited, because the mass of a substance deposited during electrolysis is directly proportional to the quantity of electricity passed through the cell. Which sequence of reagents converts propene to propanol. Okay, so for propene, before propanol, we need to use HCl to produce chloropropane. Okay, and then from this we will produce propanol. So it's too far. Propanol. So we need NaOH. So Cl from here will be substituted by OH, becomes propanol. And we need potassium permanganate to oxidize propanol, becomes propanol. Alright, so the answer is A. How many dichlorinated butane isomers can be formed by dehalogenations of CH3, CH2, CH2, CH3, which is butane, with excess Cl2 in the presence of UV light? There is no other way. You need to draw and find the possibilities of isomers for this reaction between butane and Cl2. Okay, we start first the possibility of the structure. CH3, COH2, CH with Cl, and then CH2. Okay, the name will be 1.2 dichlorobutane. And the second one, CH2, I'll put Cl here, CH2, CH2, and CH2 with Cl. So 1.4 dichlorobutane. And the third one, CH3CH, and then Cl, CH2CH2, and then Cl here. So that would be 1.3 dichlorobutane. And the fourth one would be CH3, CH, that would be here, and that will be here as well. And then CH3, different positions of Cl2. So 1.3. This one is 2.4. Yeah, sorry. This one 2.4. And this one 2.3 dichlorobutane. Let me check again. So 1.2, 1.4, 2.4, 2.3 dichlorobutane. And next is CH3, CH in the middle now, 2.3, yeah, correct. And then CH3, Cl, and then let me just put it here for both Cl, Cl, and CH, CH2, CH3. So that would be 1.1 dichlorobutane, and the other one is CH3, Cl, Cl, CH2, CH3. So that would be 2.2 dichlorobutane. You cannot put right here because it's symmetrical, so that would be 2.2 as well. So the answer is 6. There is no other way except you try to find out any kind of possibilities of the isomers with not the same of naming or structure, and that's the only way to find the isomers. Which is the homologous series? Homologous series should be defined different from next by a CH2 unit consistently. So that would be here. Okay, so plus CH2 will be C3H4 and C4H6. So you just need to add 1C and 2H. So that would be the homologous series. Which reaction involves homolytic fission? It's A, So when CH4 reacts with Cl2, Cl2 undergoes homolytic fission, forming two chlorine radical first. So Cl2 will form radical chlorine first, and then CH4 will react with chlorine radical, produce CH3 radical and Cl. For the second one is the nucleophilic substitution. Okay, so that would be CH3OH plus NABR. And for the third one, it's also nucleophilic substitution. So that would be CH3 times 3 COH plus NABR. And the last one is nitration of, this will be NO2 plus, so it's a nitration of benzene. Which structure represents a repeating unit of a polymer formed from propene? So these are propene. So to make the polymer, you will start CH3 and then C and then H and then CH2, this one. So the answer is A. What is the product of the reaction of propanol with lithium aluminum hydride LiAlH4? This is a reduction reagent. Okay, so aldehyde with the of this four option. So from propanol, when we do oxidation, it will form propanol. Okay, so if you do a reduction, will form propanol. So it's C. It should be 1-ol, not 2-ol, because 1-ol is a primary alcohol that will produce propanol and propanoic acid. But for propan 2-ol is a secondary alcohol. When you oxidize, will produce propanol. So it's not the correct answer. Number 38, how many phenols are observed in the H&MR spectrum of this compound? As you can see, they are symmetrical. So if it's symmetrical, of course, H&MR phenol that will be produced is only one, as it has one H type of environment. (20 centimeter cube of 1 mole decimeter cube sulfuric acid was added dropwise to 20 centimeter cube of 1 molar barium hydroxide, producing a precipitate of barium sulfate. Okay, the answer is B. This curve indicates decrease in conductivity as more H2SO4. So as more H2SO4 is added, it reacts with barium hydroxide, producing barium sulfate solid. This precipitation removes ions from the solution. Therefore, the conductivity will decrease. So the conductivity decrease as you add volume of H2SO4. Given equimolar concentrations, which substance would produce the strongest phenol in H&MR spectrum? As I can see here, these are the standard. Okay, it's TMS. It's very simple. So TMS produce very sharp peak and it is used as a standard. Okay, so it's produced single sharp peak. This is TMS. So the answer is D. If you check the first one has CH3 and CH. Of course, CH3 is symmetrical, so it connected to the same C, so you will have 2 phenol. And B, you have C6H6 contains 6 equivalent halogens, produce a moderate phenol. This is 9, this is 6, and this one is 18, but this one is 12. However, the presence of Si, which does not exhibit signal in proton NMR, so the observed signal only from the methyl group. But the key point here, this one is TMS. TMS produced very sharp peak, and it is used as a standard or reference peak and produce a very single sharp peak in the NMR spectrum. Alright, so that's all for the explanation chemistry paper 1 higher level May 2022 time zone 2. If you find this video is helpful for you to prepare for the exam or revision, don't forget to subscribe to my channel and let your other friend knows about my channels as well, because I'm going to explain other past year papers as well, so you guys can study together. So that's all for today, and bye for now.